Alright guys, part 1 of 9.5 is all about finding the least common multiple. And you guys have done this with numbers before, but now we're doing it with algebraic expressions. So to review, finding the least common multiple of a number, what we do, or why we do this, is because we're working with fractions. So let's say that I have the fraction 1/4 and you're trying to add 1/6. What you're trying to find is the least common multiple of 4 and 6. So if you list out the multiples of 4 and 6, so if we go 4, 8, 12, 16, 20, 24, the multiples of 6, 6, 12, 18, 24, 30, 36. What you see is that they have common multiples of 24 and 12. 12 being less or the least common multiple. So you ask yourself, what do I multiply 1/4 by to get it over 12? Well, you multiply by 3 on top and bottom. And then what do you multiply 1/6 by to have a 12 on the bottom? Well, 2. So you would really be adding 3/12 plus 2/12 equals 5/12. But there's possibly a quicker way. I personally don't think it's quicker, but it might be easier for some of you, and it's more helpful when we're using more complex algebraic equations. So, and I'm going to show you that right now. Let me insert a new slide. So instead of going through all of those steps of finding the least common multiple, what you can do is, let's say that we're staying with 1/4 plus 1/6. What you can do is take these denominators and you can use prime factorization. Prime factorization is where you find the numbers, the prime numbers, such as 2, 3, 5, 7, 11, 13. Prime numbers are numbers that are only divisible by themselves or 1. 2 is only divisible by 2 or 1. 3 is only divisible by 2 or 1. 4 is divisible by both 2 and 1. That's why I counted it out, or I didn't include it. 5, same thing. So what you're saying, or what you want to do to this 1/4, is you want to rewrite 4 as a factored number with prime numbers. So you say 4 divided by 2 is 2. So I can write 1/4 as 1 divided by 2 times 2. Then what you can do is the same thing with the 6. 1 divided by 6, well, 6 divided by 2, and that's what you're going to want to do. You're going to want to start with dividing by 2 as far as you can, and then start dividing by 3, then start dividing by 5, and so forth. So you do 6 divided by 2, and you're left with 3, which is also a prime number. From there, you say, what would be the number that this denominator has that this doesn't? Well, they both have a 2, but this denominator has 2 2's. So what you would do is multiply both the top by 2 and the bottom by 2. So both denominators have 2 2's. Then you look at this original denominator of 2 times 3, and you ask yourself, what does this denominator have that this doesn't? Well, this denominator has a 3. So you would multiply both the top and bottom by 3. So each denominator has a 2 times a 2 times a 3. And 2 times 2 times 3 is 12. So in each case, 3 times 1 is 3 over 12, plus 2 times 1 is 2 over 12, and we get the same thing, 5/12. So that is the use of prime factorization. Now we are going to find the least common multiple of algebraic expressions. Here's how we do it. So we want to factor first this expression. First thing I see is that 4 goes into 4 and negative 36. So I'm going to factor out a 4. Don't worry about this expression yet. Let's just start with the 4x squared minus 36. Factor out the 4. And you're left with x squared minus 9. From there, you're going to factor out this quadratic. We see it's a difference of squares. So I leave the 4 out, and I can rewrite this as x plus 3 times x minus 3. So the quadratic has been factored, but the 4 hasn't been factored using prime factorization. Going back to my little chart here, see what is it, or how many times can we divide by 2, then by 3, then 5, and so forth. Well, 4 can be divided by 2, and we're left with 2 times 2. So the total factorization would be 2 times 2 times x plus 3 times x minus 3. Now I'm going to do the same thing to this second expression. I ask myself, okay, what number goes into 6, 36, and 54? It would be 6. I'll have 6 pulled out, left with x squared plus 6x plus 9. Then I ask myself, can I factor this part? Sure I can. I'll have x plus 3 and x plus 3. Now I'm going to have to make sure that I factor or prime factor out the 6. You divide by 2, you're left with 3. 3 is a prime number, so we can rewrite 6 as 2 times 3 times the x plus 3 times the x plus 3. Next you say, alright, I am going to cross out any factors out of both of them that occur more, or that repeat basically. So in the not within the same factor, but repeat in the other factor. So I say I have a 2, it repeats in this expression, but I want to get rid of any 2 that occurs in the other expression. So I'm going to cross that 2 out. Then I'm looking at x plus 3. It doesn't repeat here, and if I see another x plus 3, that would be a repeat. Then I look and I say, okay, x minus 3. Do I have another x minus 3 that repeats over here? No. So my final factorization, or least common multiple, would be 2 times 2 times 3 times x plus 3 times x minus 3 times x plus 3. Make sure that you understand that it is okay for a factor to repeat within the first factorization, but if you see one over here and then you see another one over here, you cancel them out. I would need another x plus 3 in this factor to cancel this one out. So that's why I kept this. Finally, you put these together. 2 times 2 times 3 is 12. And then x plus 3 times x plus 3. Anything times itself is squared. And then we're multiplying by x minus 3. Now I realize that might be kind of weird when we get down to this point. That's why we're going to do some more practice with this. So first thing with this factor out any number that we can. I see right off the bat I can factor out a 3. Then with the quadratic, I can factor that into x minus 5 and x plus 2. Then with the other expression, and realize that I can't simplify this 3 down because it's already a prime number. So I can't break it into more prime numbers. With the 6x plus 30, I can factor out a 6. I'm going to be left with x plus 5. And then you're done. Now you say, alright, 3, I only have one 3 in this factorization. And if I have another 3 in the other one, I'll cancel it out. Don't have another one. Then I have x minus 5. In this one, if I see an x minus 5 in the other one, I'll cancel it out. Then if I have an x plus 2 in this, I don't have another x plus 2 to cancel out. So keep it all. But I forgot one thing. What I did is I forgot to do prime factorization on the 6. 6 divided by 2 is 3. That makes this into 2 times 3 times x plus 5. Oh wait, now I have some repeat. I have a 3 in the first factorization and I have a 3 in the second factorization. What happens is it cancels out. So I'm going to be left with the 3 times 2 and then the x minus 5, x plus 2, and x plus 5. Simplify the 3 minus 2, or 3 times 2, excuse me. That becomes 6, x minus 5, x plus 2, x plus 5. That is the least common multiple. Try one more. Maybe try to stop the video here, do this on your own, and then check it against mine. Okay, so out of the first expression, I can factor out a 5. Then I can take that quadratic, keep the 5 out, and turn that into x plus 2 times x plus 1. And then with the 5, that's already a prime number, so I can't do anything with it. With the second expression, I can factor out 2. And I'm going to be left with x squared minus 4. The x squared minus 4 is the difference of squares, so leave the 2 out, but I can turn that into x plus 2 times x minus 2. That came from the x squared minus 4. Now I go through and I say, alright, I have a 5 in the left factorization. Do I have a repeat in the other? No. So I can write that down. Then I have an x plus 2 in the first factorization. Do I have an x plus 2 over here? Yes, I do. So I'm going to cancel this one out. Then I have an x plus 1 in this factorization. Do I have another? Nope. So it doesn't cancel out. And then the ones that aren't canceled out from this, we just bring down. Times 2 times x minus 2. Take the 5 times the 2, you get 10. x plus 2, x plus 1, and x minus 2. We won't combine them. Let's leave them factored. And that is it for this video. I will do adding, subtracting rational expressions in the next one.